There are billions of Earth-like planets out there in the Milky Way, probably trillions. So where is everybody? That's the Fermi Paradox. And one answer is terrifying. The Great Filter? Okay, let's start at the beginning. What do we know? First, the universe is really big. There are at least 100 billion Earth-like planets out there. Second, we are alone. So far, we haven't found any aliens. And third, we have no evidence that any alien species has ever visited Earth. Now, for something to be considered a filter, it has to prevent a species from becoming like us or further. One possible filter could be that life doesn't get a chance to evolve in the first place. Maybe the conditions for life just aren't right very often. Or maybe life arises but doesn't last long. On Earth, about 99.9% of all species that ever lived are now extinct. The chances are that intelligent life might follow a similar path. In fact, fossils tell us that there were probably several mass extinctions before the one that killed off the dinosaurs. Maybe intelligent life goes through a similar fate, or perhaps intelligent life does make it past the extinction event, but then destroys itself, say through nuclear war or ecological collapse. We can't really rule that out, although we haven't seen any signs of nuclear war or ecological collapse elsewhere. We have seen it happen here. So, it's possible that some planets just have a self-destruct button. Of course, there's also the possibility that there's nothing wrong with our planet, that we're just really far away from other civilizations. Maybe the Milky Way is just really big and empty. But if that were true, then civilizations should still have a chance to meet up before they die out. They could travel between star systems, even if it takes thousands of years. There should be lots of dead planets with failed civilizations along the way. But we don't see those either. So what does that mean? Well, there are two possibilities. Either we are early or we are doomed. Let's start with the idea that we are early. This is the first intelligent life in the galaxy. No other species has made it to this point. If that's true, then we get to pick what happens next. We can choose to destroy ourselves, or we can choose to continue on to greater things. It's up to us. But what if we are doomed? What if we are not the first intelligent species, but we are the 99.9% that didn't make it? If that's true, then the Great Filter isn't behind us. It's in front of us. We haven't passed it yet. We are the filter. We keep choosing to destroy ourselves over and over again. Extinction becomes our fate. Okay, so why should we care whether we are early or doomed? Does it really matter? Well, yes, it actually does matter. Because if we are early, then there is a chance to get it right, to break the cycle. If we are doomed, then there is no chance. It's already been decided. We will die out, like all the rest. This question of whether we will pass the Great Filter or vanish like the rest is one of the most important questions we can ask. It's one of the reasons we explore the universe. It's one of the reasons we search for life elsewhere. It's one of the reasons we try to understand intelligence and consciousness. If we are early, then everything we do now will affect what happens next. If we are doomed, then everything we do now won't make any difference. Okay, so where does that leave us? Well, I don't know. I guess it depends on whether we want to be optimists or pessimists. Are we early or are we doomed? Will we pass the Great Filter or vanish like the rest? I don't know the answer, but I think it's worth asking the question. If you enjoyed this video, you may enjoy the Show Space series in partnership with NASA. You'll learn about the amazing missions exploring the solar system and beyond. And you'll hear from the scientists and engineers who work on these missions and what they've discovered. It's fun and informative. Check it out. Thanks for watching.